I'm Anil Kumar, and in this video we will understand in details how to sketch transformed exponential function. I may discuss two different methods with you to show these transformations, and I hope they will really help you to understand the whole concept. The question here is, explain the steps and sketch the graph of g of x equals to minus 2 times 2 to the power of minus x plus 4 plus 3. We already have graph of 2 to the power of x. This is 2 to the power of x graph given to you. Now, when you have a function like this, it is good to rewrite the function with coefficient of x factored, right? So we'll factor that. So we can write this as 2 to the power of minus. So factor out minus, you get x minus 4. Do you see that? Plus 3. It makes huge difference. That could be an error for some students. Now, so that is the first step, okay? Once you have factored, you may be required to write down the transformations. So I prefer to write transformations from left to right. So in that case, what we will do is we'll start from the reflection. This is that minus sign here. It says reflection on x-axis, right? Then we have 2, which is vertical stretch. So it is vertical stretch by factor. Factor because it gets multiplied, right? Factor by factor of 2. Okay. And then here we have horizontal reflection, that is reflection on y-axis. And then we have minus 4, that means moving 4 units right and 3 units up. So these are translations. So let me write this as 4 units right and 3 units up. So these are the transformations for the given function. Now, we can actually sketch it in two different methods. One of the methods is to find image points. And the other method, let me write this as method 1, and the method 2 is to do steps. Graph in steps as in transformation, right? So let us discuss image points first. Now in image points, what's happening here is that if I have x, y, okay, let me write down image points here. If I have x and y coordinates on the function, then here, because of the transformation, the x values will be negative, and then you have to add 4. So it will be minus x plus 4, moving 4 units right. So we've taken care of 4 units right and reflection on y-axis. As far as the y points are concerned, its value will be multiplied by minus 2, that is taking care of reflection and vertical stretch. So minus 2y, and then 3 units up means plus 3. Okay. So we have taken care of all the transformations. So what we can do here is we can kind of make a table of values and get some points. Now the question is, which are important points to consider? Okay, so the points to consider are always, this is a very good point. So at 0, the value of exponential function is 1. So let me write down here 0, 1. And then a good point is, if I write minus 1 in this case for 2 to the power of x, we get, for minus 1 it will be half, right? And if I write 1, it will be 2. So for 1, it is going to be 2 to the power of 1 is going to be 2. So these 3 points are very good points. We could also consider more points, but I prefer to use horizontal asymptote itself as a very good point to consider. So we have horizontal asymptote as the x-axis. So we say this is y equals to 0. Okay, so that is your x-axis, which is horizontal asymptote. Now, let us apply the transformation to get the transform points. So, minus 1 times minus, that is replacing x with minus 1 gives me plus 1. So plus 1 plus 4 is 5. So x value is 5. Half times minus 2 is minus 1. Plus 3 is plus 2. So 5, 2 is the transform point for this one. Okay. For 0, 1, we are left with 4 for x, and for 1, minus 2 plus 3 is 1. 1 and 2, that means this point, 1 and 2. If I write 1 here, I get plus 3. If I write 2 here, minus 4 plus 3 is minus 1. Now, horizontal asymptote. Horizontal asymptote has moved 3 units up, so I'll write this as horizontal asymptote will be y equals to 3. So these are the transform points. Now, let us sketch the function. So it's a good practice to sketch horizontal asymptote first, which is at y equals to 3. So it makes sense since the function is translated 3 units up. So I'm just sketching this y equals to 3 with a dotted line. Okay, so this is my horizontal asymptote. Right? So let me write this as y equals to 3. And now we'll plot the other points. 5, 2. So 5 and 2 is right there. 4 and 1, 4 and 1 is there. 3 minus 1, 3 minus 1 is there. So these are the 3 points. We could have taken some more, right? But anyway, you get an idea. So this sketch of the graph will be kind of like this. Do you see that? So that is how the final graph g of x is going to look like. So that is to sketch from the points. Now I will show you the second method, that is to follow the steps and sketch the function. Okay, so let's begin with the vertical stretch and reflection. So minus 2. So I'm incorporating first 2 transformations in my first step. That is reflection on x-axis and vertical stretch by a factor of 2. It is as good as multiplying all y values by minus 2. So this is half, right? So half times minus 2 will be minus 1. 1 times minus 2 will be minus 2. 2 times minus 2 will be minus 4, right? And this is approaching 0 as x approaches a very high value. So we get a graph which is kind of like this. Do you see that? So this is the graph for, let me write here, minus 2 and within bracket 2 to the power of x. So we have incorporated the first step. Now let me take care of the horizontal part, which is reflection on y-axis. So this is my second step. I'm going to reflect them horizontally on y-axis. That really means this point will be 1 unit to the right, reflection, right? This will remain here, and that will come 1 unit to left, right? So these points will be like moving this side. So I could sketch this graph. I'm going to sketch it slightly lighter. So this is after sketch number 2. Now sketch number, second step is the spin graph, and the final is translation. So let me call this as the final step, 4 right, 3 up. So let's consider this point. So 4 right, 1, 2, 3, 4, and 3 up, 1, 2, 3. So you reach that place. Do you see that? Okay, let's take this point. 4 right, 1, 2, 3, 4, and 3 up, 1, 2, 3. So this is my next point. Take this, 1, 2, 3, 4, and 1, 2, 3, third point. So we land up in the final position as expected. So the second method gives you the graph without any calculation, right? So as the case may be, you can adopt any of these methods to sketch transformed exponential function. Well, the strategy which you have learned in this video can be applied for any transformed functions. We'll take up another example with reciprocal functions, and I hope you should be in a position to do it on your own. I'm Anil Kumar. You can subscribe and share my videos. Thank you and all the best.